Let's continue. The next concept that we are going to look is called as the iteration through these arrays. So we'll check out how do we iterate through these arrays that we have created. Right, so this is called as iterating through the arrays. We have to go through the arrays one by one, right? So for a one-dimensional array, right, or two-dimensional array and multiple dimensions of the array, we can definitely use the normal method, that is the for loop in Python. Is equal to np dot array let me create 1 comma 2 comma 3 comma 4. This is the array that I create. Then I want to iterate through what you call every element of this array. So when I say I want to iterate through every element of this array, right, simply I will use a for loop for x in this array, that is my array 28. For every element in this, you can go with this. You can do whatever you want. You can print x square, right? Whichever operation you want to do, element by element, you can definitely do this. All right. So I'll just print that x, right? It prints out element by element. What happens if I try to iterate through it 2D? All right. Iterating a 2D array, if you want to do that, let's create my 9 is equal to np dot array. Let's create a two-dimensional case. 1 2 3. This is a 2D case. Then for x in my array 29. Now here what happens is it will go through the rows. So you see, you are going to print row by row. All right. So here the for loop goes through the rows. That is what is important. Now, if you want to iterate through the elements of a two-dimensional array, right, I will consider a row first, and inside the row I will go with the element. Okay, so this is important. I need to remember. So to iterate elements of a 2D array, sorry, a 2D array. If you want to do that, if you want to go through this, let's create a 29 itself, right? I'll write that again. For, let's say, x in my array 29. This means x is a row. Each row has several elements, so you go for another for y in x. Y is an element. You will print this y. Okay, so that's how it is. If you go for a higher dimensions, definitely you are supposed to, if you want to access the element by element of a three-dimensional array, you know what you are supposed to do. Correct? Let's create that. Let's check that as well. So my array 30 is equal to np dot array. I need a 3 dimensions. So inside this, I'm supposed to write a 2 dimension. So inside each of them, I'll write a 1 dimension. Okay, so this is 1, 2, 3. I'll write another dimension 4, 5, 6. Then let's create dimensions again 7, 8, 9, followed by 10, 11. Okay, now it's anyway. I know that this is a 3D case, and now let me try to print the same thing. So for x in my array 30, x is going to read the dimensions now. How many pages? Every page by page it is going to read. Okay, if I write print x, it will print page by page. So you see that this is a page, then it printed out the second page. Okay, what I am supposed to do, if I try to, let me copy. For my array in this, I'll say one more for say y in x, I print y. Now you see you are actually printing the rows. If you want to go to the elements, y in x, go ahead. X is the elements as say z in y. Print the z. You see you are actually accessing the element by element. All right, right. Then instead of going in this method, right, we have actually a function. All right, that function is called as nditer, nditer. So I'll show you what it is. So if you want to iterating through the arrays, we can use a function, built-in function. So that is called as nd iteration. Right. So again, I can definitely use this nd iter inside what is called as the for loop. It will be very easy for us to implement. So let me show you that. Arrays up to 30. So my array 31 is equal to, it is np dot array. Let me try to create a 3-dimensional case. So this is 3 dimension. I should use two dimensions here. So inside each one, I'll enter a case, or I think I have the 30 itself, right? Already I have, sorry, I don't need that. I can use it. I'll just print that once again. So, and my array 30. So just to see that it's a 3D case. Now for x in, simply use np dot nd for n-dimensional iteration on this array. Whichever array you are actually using, you just use that array's name here. That is my array 30. Simply say print x. Oh, my mistake. I think I made a spelling error. This is capital. Okay, so directly you can access the elements of n dimension, because otherwise you don't have any access to read the element by element, okay, of a multi-dimensional case. So if you want to use a single for loop for this, the np.nd iter is the is the function, right, that we can use. All right, now what if I want to skip iterating using different step size? Is it possible to iterate in the sense I can actually skip something, some elements while doing the iteration? Is it possible? So the answer is yes, right? I'll just write a side heading such as iterating with step size. So all right, example, again this is an example, you can do anything like this. So I just write example. So I want to iterate iterate through a 2D array skipping one element at a time. In the sense I want to write every alternative entry. Right, so let's create a 2D array first. My array 31 is equal to np dot array. So I need to create a 2-dimension 1, 2, 3, 4. Seven, 8. Okay, so this is the case. I'll print my array 31 prints out. Okay, we have this. Now I want to do the same thing. I want to iterate through the element by element, but when you do that, you want to skip element one by one. So again, you can go with the for loop. X in, it has to be np dot nditer, nd iteration of that array which you want to consider, that is my array 31. But now you need to say that go through all the rows, but when you go through the columns starting till the end with the step size of 2. Go like this. When you do that, you print. So you see, in this I read the first element, then skip the next element, third, skip the next element, this, skip the next element, 7, and so on. So you are reading it in this way. All right, now when you read in this particular fashion, it is always possible to do the n-dimensional enumeration. If you remember the enumerate was a function we have used in the basic Python classes, where you will try to identify what is the index value. If you want to get that, you can use the enumerate function for list, tuples, and so on. We have already used that, but our intention now is, can we do the same thing here? Can I try to find out the index value? Can I try to hold the index value when I do this kind of calculation, right? It is using this NumPy. So yes, answer is true. So whatever we have discussed over there, right, we can do the same thing here, but only the function is changed to nd enumerate. Let me give an example. This is equal to np dot it's a small letter, np dot array of. All right, so this is what I create. I know this is going to be a 1D case. So what you are supposed to do here, you will use the np.nd enumerate function. So I have to use a for loop because you are iterating. So definitely you will go with the for loop itself. So for, now you see, you have to give two values. One is index, one is, so similar case we have used in the basic Python session. So this is I comma v, I for index, V for value in this np dot nd enumerate of that array which you are considering. Okay, my array 2. So inside this, when you do, right, you try to print I comma v. So it says 0th element is 1, first element is z, and so on. Right? So we can do the same thing with the two-dimensional array as well. So let me try to copy this. Okay, it's okay, already there. My array 31. So I can do that for a 2D, 3D case as well. I'll show you the 2D case. 31 is a two-dimensional case, and if I run that, yes. So you see the index will be 0, 0, 0, 1, etc. So same thing goes well with the multi-dimensional case as well. 3D, 4D, and higher dimension. Yes, you can do this. You can apply and you can try to find out this. Okay, then let's move ahead. The next concept which is important under the NumPy is joining, right? What if I have multiple ND arrays and I want to join them? Right now, right, it's very simple. Like you can join the arrays by using what is called as a concatenate function, right? The same thing is applicable for two dimension and multi dimensions as well. But let's look at the 2D case, 1D case followed by a 2D case. Okay, so let me create two one-dimensional arrays. My array 32 is there, so 33 is equal to np dot array. So this is 1. Is equal to np dot array right. So this is the case. All right, now what I want to do here, I want to get a new array, that is my array 5 is equal to, this is np dot concatenate the two arrays print my array 35. Sorry, let me just check only integer. What was my mistake? Concatenate. Integer scalar arrays can be converted to a scalar index. All right, it's not a problem, right? Should not be any array. My np dot array, np dot concatenate. Yeah, sorry, my mistake. I'm supposed to use inside this. I have to use another bracket. So that was my mistake. Sorry about that. I will. Okay. So this is actually, this is same as, let me show something. Whenever I try to write like this, I can also specify, let me make it as the next one. This is 36 is equal to, I can specify how I want to concatenate, right? This is same as x is equal to 0. Axis equal to 0 in the sense indicates, right, you attach it to the right side, right? My array 33 is there. To the right side of that, you attach the my array 34. Okay, now what I try to do here, I'll try to copy this, I'll paste, and I'll show you what if I want the concatenation one below the other. You are increasing the rows, right? So this is 37. You just change this axis to 1. Oh, what happened? My array 37 size is same, right? Okay, but still why I'm getting this error? My array 57 np dot concatenate 30 axis equal to 1. It says axis 1 is out of bound for array of dimension 1. Okay. So I have both arrays as one dimension. Sorry, this is not going to work here. It's absolutely my mistake. Sorry, I'll change this. What I do, I'll create two different arrays, let's say, and right. Okay. So let me try to create two arrays now, because it says axis 1 is out of bound. In the sense, I can concatenate two 2D arrays. Right? I was trying to do that, but I didn't consider that both are 1D arrays. So, now, uh, let's do the same thing. np dot array np dot array of, I need to enter 2D cases, say 1 comma 2. Then I'll write 3. Sorry, this is 3 comma 4. So this is one array which I create, and my array 38 is equal to np dot array. I'll create another 2D case, right? Inside this, I'll write two 1 dimensions, 5 and 6, 7 and 8. Okay, right? So I'm I'm able to get this. Now I'll create my array 9 is equal to np concatenate. It's the same thing I'm writing. So I will write the two arrays, that is my array 37 and my array 38. Then I'll say axis equal to, what's the, again the same. Okay, it's Aries spelling mistake, axis. Okay, now let me print that. Print my array 39. So you can see that, right? So this is how it's going to happen. I had two arrays and I'm attaching this in this way. Now we can actually use another function that is called as a stack function. So joining the arrays is also possible by using another method that is actually called as a stack. So let's look at that. Stacking now. So if you want to use the stacking to do this, let's say I already have the 1D arrays with me, that is 33 and 34. Let me print them. My array 33, 1 dimension, my array 34. Okay, so those are the two arrays I have, and Now I'll create a new array, my array number 40, that is equal to np dot stack. Okay, so you just have to mention the two arrays which you want to stack. My array 33, I will use, I think I have to use another one, otherwise it will give an error. So my array 33, my array 34, and you can specify how you want to do it. If you don't specify, right, you can, it automatically takes as axis equal to 0. I'll write axis equal to 1, right? That means it's actually column wise. Then check my array for, inspect that, so you can see that it's a stacking considering this. Now you can do the same thing. This is like stacking considering them as columns. That's what happened here. If you want to consider them stacking in the form of rows, right? Is it possible? Yes, that's also possible. We can do the following. Okay, I have the same arrays 33 and 34 with me, right? I will say my 41 is equal to, this is np dot h stack, horizontal stack. Specify my array 33, my 34, and inspect my array 41. So stacking, this is a row wise. Okay, but anyway, I might want the stacking along the columns as well. It depends on our application, but yes, we have a facility to do that. So if you want to do the stacking along columns, right, I will use my head stack as a v stack as a function. My 42 is equal to np dot v stack. This is vertical stack of my array. So I think I'm going to use the same 33 and 34. Let me inspect my array 42 after this is done. Okay, so these are the various options that we have here, right, to do the clubbing or the concatenation, right? That can be done in the various options. So whenever we can actually concatenate, there has to be an option to do the splitting as well. So we are going to check that now. How to do the various splits. All right, so splitting is also possible. I just have to use a function called array underscore split. So we pass the array to that, and we will say that how many splits you want. Okay, so we can split that as per our requirement. It will consider equal number of elements and it will do a split. All right, so let's see that example now. I think we have my array 41, which is actually a one-dimensional array. I'll type that my array 41. Okay, I have this. Now I'll try to split that. So 3 is equal to, this is np dot array underscore split. which array you want to split, you specify that. That is my array 41. And let's say I want to cut this into 3 pieces. Right, so now my 43, inspect. All right, so you can see that it has been split into 3 numbers, right? So you return an array containing 3 different arrays in it. Okay, but it is always not required that you will enter the right number of splits here, right? So in such case, if at all you enter a different number, so let me show you that. Let me say I want this is the new array number is 44, and let's say I'll say that I'll ask that split it into 4 pieces, not just the 3. See, 4 pieces. Actually, this cannot be split into 4 pieces equally, right? But as you can see, it will not throw any error. So it will not throw any error. It will, right, select uh, unequal pieces, and it somehow it will make them into the 4 pieces as it is. Okay, so that's a method, right? Anyway, there's no facility that you can actually, right, split it into pieces. Now, how do I access? I already have my array 43, which is created by splitting them into 3 pieces. Okay, can you access the individual pieces of that? If you want to answer that, yes, the answer is like this. So my, let me print it once again. That is 43. So if you want to access the first piece, my array, that is 43, first piece is indexed as 0. So you see, you can access that. Okay, like that. If you change this, so if you want to access the last piece, you will just enter say 0 1 2. Okay, so that means it's a last piece. Okay, and yes, this is going to work even for 2-dimensional cases, right? And right, and multiple cases as well. So first, let's check this 2-dimensional. Okay, again, we can use the same idea here, same function. So let me show you. First, let me write splitting a 2D array. Let me create my equal to np dot array. I'll create 1 comma 2, then 3 comma 4, 5 comma 6, then 7 comma 8. I think it's a 2D case, right? So sorry, I need to use another square bracket at the beginning and at the end. So this is a 2D case, and I will say I'll create my array 6 is equal to its np dot array split, array underscore split, my array that is 5 comma 3, not 3, I'll enter 2 because equal pieces I just can, right? Then I'll inspect my array 46. So you have 2 arrays available here. So this is pretty much same. Okay, if you want, actually you can even specify in which direction you want to split, right, by mentioning the axis as well. Okay, so how many pieces you want, and uh, in what dimension. Axis can also be specified over here. Okay, so let me show you that. So this is a 47. I'll say this into two pieces and it's equal to 1. Yes, so you can see that, right? Axis is 1 means vertically you are getting arrays. So again, we have alternative solution to this whole operation. That is actually by using the horizontal split and the vertical split. Both are possible. So I'll show you the H split. So this is say 48 is equal to, I'll just write H split array comma 2 pieces. That's all. I don't have to specify. H means it understands. You have a split like this. So even the V splits are possible, right? If required, we can do that. Then, so the next concept that we will be discussing here is how to search. So we'll search something. Okay. So there is a method called as where. So if at all we want to find out an element, right? If you want to search an array for certain value, and I want to identify which particular location it is there, if I want to find that out, then I'm going to use the where function. All right, so let's see that. Is equal to, let me write this as np dot array. I'll create, let's see, this is the one, and I'll say x equal to np dot where my array 49 equal to 4. Then I inspect this x. At these indices, index values are 2, 5, and 6. Right? This can be even applicable, right? I can check this for any condition. You see that here I have actually equal to 4, right? I can try to find out where the elements are even, right? Percentage 2 equal to 0. You see, it works. Like, in the sense, you can even try to find out the various values that are required, and depending upon the conditions you can actually apply over here, right? But the where function works in the same fashion. Okay, then we can do a binary search, right? Earlier we have seen that same similar binary search option was available in the normal or the basics of Python, where, right, we use a function called sorted, and that helped us, right, to identify the index where I can insert a specific number, so that the array still remains in the what you call ascending order, right? The condition is that you have to enter something which is in the ascending order. Your array should be in the ascending order. Okay, so let's try to use the same concept here, but you see here we are supposed to use the search sorted function. Only that is a difference. So let's create an array is equal to np dot array of let's say this is the array. Now I say that x is equal to np dot search sorted the above array, that is my array, comma, let me say I want to put a number 77 and then I search for it. So we say at index 1 we can put it. Okay, it's applicable even you can do the search from the right side. Okay, so that is possible. Let me show you. So my array 50 77, then I say sometimes you might require this position from the right side, so you just have to say right. Okay, so you can insert at this particular position. All right, so that's how we get the answer. Right, then let's go ahead. The next thing that we want to write here is let's say I can even put the multiple numbers over there, right? Using the same concept. How to insert multiple values? Okay, and let's see, right? Let's try to do this, and let me create another one for this because I want to insert say multiple elements. Okay, so my array 51 equal to np dot array of, say I'll write 1 3 7, then x equal to np dot search sorted the array, comma, now we enter the list itself. I want to put 2 4 and 6. So this, let me check. So it says 1 2 and 3, right? Those are the indices where you can actually put these, right? So that it still remains in the ascending order. Right? If you have an array in unsorted format, let's look at the sorting options now. So if you want to use the sorting of these arrays so that you can get unsorted, you can convert an unsorted array into the sorted array. I have a function called sort. So this is what I'm going to do next, right? So we'll try to sort. np dot array. I'll create an unsorted one, 33, 22, 10, and 44. And I'll create the result, my array equal to, this is NP, okay, or I can simply, I don't have to create a new answer. I can simply write NP dot, this is a function. Simply call the array which you want to sort. My array. So it will sort and it will print 10, 22, 33, and 44. Okay. Similarly, if you have a two-dimensional case, right, you can see that, right, it's going to sort the array in the row-wise format. All right. So my array, I'll create a 2D array with both the rows unsorted, and you will see that rows get sorted because of this, right? So this is np dot array of, and enter the two dimensions here. Say this is 33, 22, 11, and the next one is 44, 66, 55. This is what I have. I'll do the sorting again. np dot sort of this array, that is my array 53. So see, both rows will get sorted because of this. Then we have actually called as something called as a filter, right? Filtering is possible in this, what you call as the NumPy. NumPy actually supports us by doing what is called as a filtering. So based upon certain Boolean conditions, we can actually try to select some of the elements from this. Okay. So in a sense, I'm trying to create a list, create a array, and I'm also trying to create a Boolean index list. So then I'll apply, right? And I'll be able to see that I'll be filtering some of the elements from the n-dimensional array. So I'll show you that now. So let me create 54. That is equal to, let me try to create np dot array. I try to create, enter some elements. Maybe this is 11, 44, 77, 99. Okay, this is the array. Then I'll create x, which is a Boolean list saying that true, false, false, true. Now, how to use x as a filter on the elements of array? Okay, so I'll try to create a new array, that is my array 5 is equal to, I just have to say that go to the array, original array, that is my array 54, and select those elements which says x is true. Okay, and let me inspect the result, my 55. So say the length has to be same. There are 4 elements here, and I have 4 Boolean conditions here. So corresponding to the each element, 11 is true, so that's why the 11 came in the answer. 99 is also true, it came in the answer. But 44 and 77, you can see that we have the Boolean values false corresponding to them. So because of that, right, I'm not able to get this out of it. Now let's go for a problem. Let's go to a simple function, and let us try to enter something here. Right, so this is a question, a simple exercise for us. Create a filter that returns even elements from the original array. So what we do, let's say that I create an array, that is my array 56. This is equal to, let me enter some number. It has to be array, so this has to be np dot array. Let me create the numbers 1, 2, 4, 6, 5, 3, 7, 9, 8, and so on. Okay, so this is the array. Now I need to have a list which is actually going to act like a filter. So filter list, filter is a function, so I cannot give it. So filter list is equal to, let's create an empty one. All right, now for, let's say, every element in this array, that is my array 56, for every element in that. So let me check if what's the condition I'm going to check? I percentage, because I'm checking whether it's even or odd, right? So 8 percentage 2 equal to 0, right? That means I want to filter out only even numbers, right? So my filter will be true for that, correct? So filter list, to that list you append true. Okay, that is if. Else the other condition is that you don't have to check any condition, simply filter list dot append false. Okay, you come out of this for loop. Now create a new array out of it. That is let me try to get a new array with the name my array 56 is there, 57, that is equal to I have applied this filter to that existing array, that is my array 56 of filter list. So that then you print both of them. So let me first uh, print this filter list. Filter list I print, then print the result, that is my array 57. Append, sorry, my mistake. So I'll update. So out of them, you can see that in the original case, 2, 4, 6 are all together. So you got true, true, true together. Then 5, 3, 7, 8, 9. Last one is 8, which is true or dead. According to that, you could actually right. But it is sometimes it may not be required that you have to use something like some logic like this. You don't have to write a function like this to create the filter. Okay, I'll give one example wherein we can try to create the filter directly looking at the array. Okay, so let me give that example now. You can apply the filter directly by looking at this. Okay, so that is, I already have this array with me, right? I can write filter list 2 is equal to, you see, I want to look at the array. What was the array? Array is my array 56. 56. What you want to do? You take a percentage 2. That's every element divide by 2 and look at the remainder equal to 0. Okay, look at the filter list now. See, you are getting the same filter list that was printed over here, and you can simply apply that. Okay, so we can simply print this one. 56 of filter list 2 will leave the same. So that is the whole concept of filtering. Right. So once the filtering is done, then let us move into a concept that is called as the random number generation. Right. So there is what is called as a random module. So using that random module, we can actually try to generate random numbers, because one of the very important feature here in feature used that is taken from the NumPy, irrespective of whichever is your application. Maybe you are building something for machine learning, deep learning, data science, or whichever field you may be working on. But for random number generation, the best suitable what you call library to be used is the NumPy. Okay, so let's look at that now. So we'll be looking at the random number generation. It can be even considered as an application of our NumPy. So to do that, you need actually a module called random, right? So we'll write from NumPy, you import a part that is called as random, which is a module. Then now you see x is equal to random, and if you want to generate integers, random integers, you call randint, right? You specify the size, right? Maybe I'll just write 100. This means you are sorry, I'll just inspect x. So this means you are generating a number between 0 to 100. Okay, 100 does not mean that it's a size. It says that that's the what you call one number in this range, 0 to 100. If you write 50, a number between 0 to 50 will be generated. So it's a single number, right? If you want to generate, so let me show you here. This is I'll write to generate int, right? So next we'll see random float. Okay, always the floating value, it is expected right to be generated is normally between 0 to 1. So let me call that x is equal to random dot, there is a function called rand. Okay, again let me check this, inspect this x. You can see that you are generating a random number over here. Okay, but what if you want to generate a random array, right? So far we just generated a single number, but I want to generate an array now. Right? So if you want to generate this, you have a you can actually specify a parameter called the size. So just specify that you want this as your size, and that itself will be generated. So x is equal to random dot rand int, right? I'll say 1000. I want to generate the numbers 0 to 1000 and specify a size, right? So size equal to, you just have to enter inside the braces. So I want to generate 10 numbers. Okay, that is the x, and I'll check x. So you see 10 different numbers are generated between 0 to 1000. Right? So what if you want to generate a array? This is actually, when I say size equal to 10, right? This is actually, this generates right here. This is 1D array, right? But if you want to generate, say, a 2D array, right? What I try to do, I'll make only one small change in this. That will be, so just change the size to a two-dimensional entry, like so many rows. Maybe I'll write 4 rows, 3 columns. See, it generates. Same thing is applicable for float. All right. So I'll say this is floating values. If you want to do that, you just have to change it to the you just have to change the format in which you enter. So x is equal to dot rand is a function. Just say I want 5 numbers. It generates 5. So okay, so I'll just enter x once again to verify. It generates 5 random numbers. So this rand function is used to generate the random floating values between 0 and 1 always. Right? Then let me do the same thing. X is equal to random dot rand. I will enter the same number, 3 rows, 6 columns, and check x. So we can see that, right? This is how it happens. All right. Then if I don't want completely random, but I want to pick up a value out of a list at random, that is also possible. Okay, so let's call it as a generation of random numbers from an array. So this is what I want to do, right? In such case, I can specify that by using what is called as a choice, right? So that means, let me say x equal to random dot choice. You will specify, right? 3 comma 5 comma 7 comma 9, and then you say that, show me that what you have selected, it's this. What if you want to select a specific size from these numbers? In the sense, I want to generate a different size, such as say, let me actually, you can specify that here by saying the size, because the size keyword already we have seen, right? So we just have to say that size equal to 2 comma 3, right? You see, 2 comma 3 array is returned, but right, how it has been selected? It has been selected by a by random of a specific size, right? So that is one specific example to generate the random numbers. Now we actually have an option to go with the what you call as the random permutations. Okay, so because you see that the permutations are something like if you have a 3 to 1 as an array, the 1 to 3 is a permutation of that. So we basically have an application that is called as random permutation, right? We can do the same thing using certain functions that are available inside the NumPy. Okay, so let's look at that. Okay. So the next thing we are going to look here is about the shuffle function and the permutation function, right? So let us create an array. Is that I think we went till 55 or something. 56. Okay. Then 57 is equal to its np dot array. Let me generate 1, 2, 3, 4, 5, and I'll say x, or let me shuffle, because shuffling is pretty much easier, right? You simply say that random dot shuffle me this array. And then you inspect. See, it has been shuffled. All right. I can also do the same thing by using the permutation as well. So random dot random dot permutation of the same array, that is my 57. So generating the these kind of permutations are also equally important for us. Then normally what happens is you may have to generate the specific distribution, right? A set of what you call numbers are supposed to be generated following certain distribution, right? Maybe it is something like you can have a normal distribution, binomial distribution, like that. Various distributions are supposed to be followed while printing number. So we'll look at only one of them. That's called as a normal distribution, right? Because that's pretty much widely used. Generating the numbers of specific type. So we'll look at that. So we'll look at what is called as a normal distribution. So we see that right, we have a Gaussian distribution. Upon processing that, you get a normal distribution. So in order to generate a normal distributed data, right, we always use the function called normal random dot norm. Okay, so the simplest format of this is, let me create that, random dot normal. So you simply, you don't go with any of those what do you call, out of the 3 parameters, right? You can directly apply the size itself. You can just say that I want of size equal to, you mentioned what size you want. Maybe I can write 3 cross 4, and I say okay, show me it. So all this data, whatever you see here, normal distribution is okay, something that actually looks like this. About the center, about y equal to 0, it is equally present on left and right side. So you can see that equally, the equal distribution of positive and negative numbers over here. So that's a feature of this. But Yes, as you can see here, it can say that you can actually specify the mean and the standard deviation by using two parameters, location and scale. All right, so let me show you that now. So before the size, I will specify the location should be equal to say uh, 0.5. It can be real number, all right, and the scale. What's the scale? Scale is actually the standard deviation. You can write any number here. I'll just put 2 and this. Okay, so you see that you get a different one. Now, since the mean value is positive, most of the values will be positive here. Okay, and in the visualization part and when we discuss the mathematics, maybe in the upcoming session, we will be using this more. But since we are using the NumPy for this purpose, right, I thought it is very important to use it. Okay, then right now we will move on to another part that is actually called as the U functions. All right, so it's called as the universal functions, right? And they are NumPy functions to operate on specifically n-dimensional array. So on a n-dimensional array, we can make the universal functions to operate, and you get a result that is also right. If the result is expected to be an array, right, you will get an array as an answer. So we'll be moving ahead to what is called as the universal functions or U functions. Normally, take the you can see that normally they operate on the arrays. You get a ND array as input, one or two arrays, and you can actually apply the U functions to get the result. So addition, subtraction, etc. Can be directly done using the corresponding functions. Okay, let me show you them. So let's create some arrays. NB dot array of, this is one array. Let me create another array. Y is equal to np dot array of, let's say, 11. All right, so we have created two arrays. Now we can use the function that is right. Okay, let me write a name here. This is, sorry, arithmetics. Right, I'll show you. Let me create this now, and the first thing is add. If you want to add the two arrays, simply np dot add x and y. You get a result. Similarly, if you want to do a subtraction, you can use a function called subtract. That is np dot subtract x comma y. So from x, y is subtracted and you get an answer. And if you want to do a multiplication element by element, this is np dot multiply, right? X y, you have an answer. Then even the division is possible, right? And np dot divide, I'll write now y by x, otherwise maybe. So you can see that, right? It gives you the answer in this way. Then you can even raise it to a power. Okay, so np dot power, right? You just say that x comma y. X is raised to a higher power. So you can see that if it's a larger number, right? You can see that you have bigger numbers coming in the picture. Then also you can try to find the remainder over here, that is np dot. If you want to find the remainder, you will use a function called mod. I divide y by x. Okay, so it says remainder is 0. That's why. Then right, you can actually find out even the quotient by using a function called div mod. And let me show you, there is a function called reminder function, right? That's also possible. np dot reminder x y, so you get a reminder. Then you can also do the np dot we have quotient and mod. That's actually by using what is called as div mod and say y x. So you get two arrays. One array is for quotient and one array for the remainder. And if at all you have a absolute, if you want to find out the absolute values, right? Let me show you that, right? You can use either ABS or the absolute function. Okay, so I can use any of them, right, over here. So let me show you that. Let me say that np dot absolute value of, pass an array to that. Okay, so this could be -1. This could be, oh, I need an array now, so I'll just write np dot array. I'll directly write this -1, -2, 3, 4, -1. See that every negative is actually cancelled and you got the positive numbers as answer. Okay, then we'll move further and we'll discuss about what is called as the rounding into the decimals. So rounding into decimals can be done in several ways in NumPy, because we might have to use one of them in our code. So we'll discuss about the rounding into this. So we can do the following. One is called as a truncation. You can try to truncate by using what is called as a truncation function. It's called as simply trunc. Let me give an example for each one of them now. So how to do the truncation? Let's see. np dot trunc of, enter a list. Maybe this is minus 3.1666 maybe, and I write 6.33339. Right, you see the truncation actually happens. It will remove the decimal points and return only the floating value which is closer to 0. So same thing I can even apply. I can write this fix function, okay, instead of trunc, fix. So that can be done using this method. Then let me move to the second technique we have used, truncation and fix are over. Then I'll move ahead to the rounding part. So there is a built-in function in NumPy, and it is called as around. So that around function can be used, right, in the following fashion, right? It increments the preceding digit or a decimal by 1 if it is greater than or equal to maybe the half, 50%, or else it will do nothing. So you can see an example, right? The round of the 1 decimal point, that is 3.1. You can see the next number is 6, right? It is more than 5, so it will round that to 3.2. So I'll check that. NP dot around. I'll specify the number, that is a 3 point maybe 1666. I'll take the same number, and I need to specify which one I need to consider, which particular decimal point I need to check. I'll say 2, right? So the second one it is going to consider 3.16. So the next one is also 6, so it will be implemented to 7. So you see that only the second decimal point is being considered here. So that is 6 is considered by looking at the third decimal point. So that's what is the significance of this 2. So after round, we have another truncation technique, sorry, another round off technique. It is called as a floor. All right, so there is a flooring technique. So it rounds off the decimal to the nearest lower integer. Okay, this is the example. We can check np dot floor of, let me write 2 numbers and check what happens. One is minus 4.666 and the next number is 3. Let's see. So lower number is going to come. So minus 4.6, lower number is minus 5. Floor is lower, lesser number. Okay, similar to this, I have another technique called seal. So if you take up a seal, it's like a ceiling. So what is the ceiling? Ceiling is above. So it will convert any given number into its next integer value. Right? So let's take up an example of the same thing. Same example, I'll take same numbers, but you see instead of floor, I used C. So instead of minus 5, it becomes minus 4 because a larger integer will be considered over here, and we'll be considering this, right? So seal will be considered for this. Then we'll move further. The next concept is how do we apply the logarithms in the NumPy, and also we'll look at the various bases to which you can take the log. So log to the base 2. First thing, we can basically take log to the base 2 and 10. So if you need to use log, right, 2 to get this, right? So there's a function called a range to create a range of numbers. Already we have used that. Let me directly use it. So np a range, it creates a range. Okay, I need to take a log first. So I need to, I'll say np dot, or let me assign this to something so that it becomes easy for you to understand. Okay, so x is equal to np dot range. We will say the size of 10. let me check what this x looks like. Right, starting from 1, 10 is excluded, so 1 to 10. So these are the numbers I have. Now what I do, I'll try to get the np dot log 2 to say that I want to take the log to the base 2. All right, so log to the base 2 of that x prints that. So similarly, now log to the base 10. So what do you do? It's np dot it's log 10 of the same. X is already created. I can simply try to print that. Okay, if you want to print the log to the base e, it's a natural log. Log, right? That means I can write base. What's the base of natural log? It's e. So if you want to calculate that, then you can simply try to write this. That is np dot. Simply use a log function. It means it is a natural. So that's how the logarithms are being taken over here. Then let's move to the summation part. I have two different arrays and I want to take a summation of all of them. Right? Over all the elements should be added together to get a single answer. So that actually leads to a concept that is called as the summations. So let's take up a summation now. Let's create two these things. Let me say I have an x with me. I have y. Okay, so let me change x. X is equal to np array 2, 3, 4, 5. Okay, let me keep the size same. Y is already created, so I can just write that. Now I need to use a answer that is actually sorry, I need to use a function called sum. There is a difference. Add means it's going to add element by element. We already have it. Now you want to get a summation, so np dot sum of x. So, what happened? Oh, my mistake. It has to be entered in the form of array. So np dot sum of these two x. So sums the value of your first array, that is x, and then it actually sums right in this way. Right. Then I can also specify the axis, right, in which you want to do the calculation. So x comma y comma, you specify axis equal to 1, right? In the sense 1 is an axis, right? So 0 is for columns, 1 for rows. Row wise it is adding. So first row, that's the answer. Second row, 165. Then we have another option called as cumulative sum. This is also very important, and I'll just show you what it is. Okay, so the cumulative sum comes into picture. So how do we do the cumulative sums? There is a function called cumulative, cum. So I have already x with me, right? I'll write np dot cumulative sum of that array x. So you see that if you have 1 2 3 4, the example says if you have 1 2 3 4, first number will be 1, next number will be 1 plus 2, that is 3, then 1 plus 2 plus 3, that is 6, then 1 plus 2 plus 3 plus 4, that is 10. That's why you have the answer as 1 3 6 10. Now in the similar fashion, x needs to be considered 1 2 3 4 5. So we can see that this is the answer. Okay, then in the similar way, there is what is called as a multiplication, which actually, right, multiplies two different arrays element by element. But now if I want to find the product of all the elements in an array, right, then I need to use a different function. That function is called as product, prod, right? So that's how it is done. Now let me show you that directly. So it is np dot, let me print the x once again because I'm using x for this purpose. np dot product of that x. So 1 into 2 into 3 into 4 into 5, 120. At the same time, you can apply the same thing for two different arrays, right? If you have x and y, I can definitely try to do the same thing. That is np. Let me print y once again, just to check the number of elements. Okay, we have this. Now np dot product of both x comma y. Why this is coming negative? Maybe it's too large. It should not be too large. Let me change y now. Let's see. Should not come. Let's look at that later. Let me change it to smaller numbers now. 6 comma 1 comma 5 comma 6 comma 7 comma 9. All right, let's see this and let's see this. Okay, now it's coming proper. So there is also a possibility of specifying in which axis you want to do this, right? You can specify this x comma y, and you can say axis equal to 1. So it's like the previous case, only for the first one, right, it will multiply, second one also it will. Then if at all you want to do a cumulative product, right, like a cumulative sum, there is a facility to do the cumulative product. So only change is it's not going to be cumulative sum. The function changes now. That's all. All right. So this is a cumulative product. Okay. So let's try to apply that now. np dot cumulative product of x. Already we know x, right? It's a multiplication. First element is only one number. Second element in the answer is first number into second number, and so on. So you have 5 elements, you get this. Similarly, right? You can actually try to get what is called as the differences, right, of successive elements in the array. So if at all you want to find the delta value between, right, successive elements for any application that you are going to build, this is going to be very helpful. So let's look at the differences. So example is already given here, very clear. So first answer will be 2 minus 1, then 3 minus 2, then 4 minus 2, and so on. So let me do the same thing here. It's np dot diff is a function. Apply that to x. Right, already we have x here, so I know that the difference is the same. Right, right. Now what if you want to take this difference once again on this answer? You may want to apply the, what you call, repeated difference you might want to find, right? So you see that for that also we have a solution here. You can specify a parameter called n. So if you specify uh, n as 2, so you have this 1 1 1 1, right? you will be taking the difference once again between these two. Okay, so let me try to do that. np dot def on x is my array, and say do this twice. So once when I do that, I get this answer. I already know that. Now I am doing this for another time, means this difference, its difference will be 1 minus 1 0, 1 minus 1 0, 1 minus 1 0. That's what is expected, you see, to have this. So between the two numbers, if you want to apply for something like a double differentiation, right, you can actually apply this. All right, so that's the one thing. Then LCM, very important, right? So yesterday we actually, without knowing the usage of NumPy, we were trying to implement something. So that was actually difficult, very difficult for us to implement, right? LCM of numbers. Now, let me give an example of LCM using NumPy, right? So simply you can apply np dot, there is a built-in function called LCM of, enter the number 4 and 6, answer is 12. Very straightforward. And if you have LCM of arrays, I just have to use a reduce function, because reduce is, we know that there is a reduce function which is actually present inside this. All right, it's already a universal functions in NumPy. So if at all you have array, then you will use np dot LCM dot reduce, enter. Okay, I'll create a, okay, instead of that, let me call x itself, because x is already created, right? That's the answer. Right, so now you see it's easy for us to find the answers which we had yesterday, right? I want np dot LCM reduce of np dot arrange from 1 till 21, right? So this was the answer actually we got. What's the LCM of, right, all the numbers from 1 to 20, right? So we can actually find it in a single step, right, like this. Same thing is applicable for the GCD, greatest common divisor. So np dot GCD is a function. Simply enter two numbers like 6, 9. You have an answer. Then np dot GCD of, I want to enter a NumPy array here. Okay, so I'll just enter np dot array of, enter some numbers like 20, then 8, then 32, maybe 36, etc. Right, so you see that answer. Sorry, what happened? GCD takes, didn't I close? Sorry, this is closed, this is closed. I have to close this as well, right? NP takes 2 to 3% argument, but 1 is given. So what happened? NP dot GCD dot, okay, okay, sorry. GCD takes this. It's actually, I need to reduce. So reduce. When you have multiple elements, like the LCM case, LCM of array, right? This is GCD of array. So like that, we can even find the GCDs using this fashion. Then the next thing is the trigonometric functions. Very important, because even, we always use the if at all you want to calculate the trigonometric functions of in your main applications, we still go for the NumPy itself. So all these values are actually available, and you see that the NumPy knows what is called as a pi. So you can simply write np dot pi. It knows the value. So you don't have to write a pi value equal to something. You don't have to write it. Right? So I can simply type, maybe this is np dot sine of, write a value, that is np dot pi divided by 2. You have a pi by 2, sine pi by 2 is 1. I can do that. And let me create x is equal to np dot array of, I create an array from np dot pi by 2 np dot pi by 3 np dot pi divided by 4 np dot pi divided by 6, and so on. Let me say this is the x now. Let me create x, and let me simply try to get the np dot of this x. Right? If you have a degree, if you want to enter them as degrees, let's say y is equal to np dot array. Let me assume that I have degrees present over here, like 90 degrees, 60 degrees, 45 degrees, and 30 degrees. Then actually I can still operate on this. I can find the sine, right? I need to, right, convert this in the following fashion, right? I can simply say that if you want to convert the degrees into radians, right, I can simply use np dot, or what you have in y, it is degrees, so degree radian conversion of this y, right? So you see this is pi by 2, right? This is pi by 3, then pi by 4, and pi by 6. That's it. You can do the reverse, right? That is np dot, you have radians in x, so this is radian to degrees. Call that particular array, and you have radians to degrees. What I wrote, it's rad, oh sorry, not red, my mistake, it's rad to dig. Yes, so you can see that 90, 60, 45, etc. will come into picture, right? So sine, cos, tan can be applied in a very similar fashion. Now if you want to go for an inverse, right, I have the value and I want to find its inverse. Inverse sine, inverse cosine, inverse tan are actually supported. All right, so that's actually the finding of the various angles that's possible here. So by using arc, arc sine means sine inverse, arc cos inverse, arc tan is tan inverse. So I can simply write np dot arc sine inverse of 1.0, you know that, pi by 2. All right, I can also get the hypotenuse values, using if you remember the Pythagoras theorem, that is what is called as a hypotenuse, right? So we can actually try to find that directly using a hypot values. So that is, you enter two different lengths, and you want to find out, right? If you enter the base and the perpendicular values, and it says what is the hypotenuse that is required to satisfy the Pythagoras theorem. All right, so let me try to write this np dot hypot. Right, I'll just write a base value, maybe that is 3, and 4, I know the answer to be 5. So that's how, right, we'll be able to do the calculations using this. All right, then let's go to the other important aspects of this. Let's say, what if you want to calculate the hyperbolic functions? All right, so hyperbolic functions are again supported by sine hyperbolic, cos hyperbolic, etc. So let's try to apply this. So np dot sine hyperbolic of np dot pi by, right, we have an answer. Now I already know that x contains angles in degrees, sorry, radians. So I can try to find np dot maybe cos hyperbolic of x. That's how we get this. Similarly, if you want to, this can be applicable, this can be applied for tan as well. Anyway, I'm not doing that. Let's do the inverse hyperbolic, right? Very similar to the sine hyperbolic, sorry, sine cos tan. Inverse was arc sine, arc cos, and arc tan, right? Very similar to that. Let's do this. So if you want to find the inverse, right, you can apply arc sine h, arc sine cos, and so on, right? So let's try to enter, let's try to find this, and maybe I can write np dot arc sine hyperbolic of, enter a number, maybe 1.5. You see that this is the angle in radians. You can even pass an array over here, right? And you can get the corresponding angles as and when required. All right, then almost everything we have covered that was related when we compare with the basics of what is called as the Python, basic Python, whatever types we have discussed, almost everything has come here except one, that is the set. So let's look at the sets now. Okay, so in order to create a set, I need to use a function inside NumPy. It is called as unique function. It's a unique. So let's try to create that. Let me say x is equal to np dot array of 1, 2, 1, 3, 3, 5, 4, 3. Let's see. This is what I have as x. Now np dot unique of x. See, the result is just 1 2 3 4 5. It's just because of the same fact that it selects only the unique elements once. Now let me create another set y. Y is equal to, let me check what is there in y. It's angles, right? So let me change np dot array of, let me try to write say 4 comma 5 comma 6 comma 7 comma 8 comma 9. Let's say that this is a set. Already I have a set, right? And right, if you want to find the union, right, let me write this. This is y, and if you want to find the union, I'm supposed to use a function called union1d. So union1d is a function to do this. So I can just write np dot union1d of x comma y. Let's see. Get that. Okay. Similarly, you can apply the intersection. Right. Let's see the intersection. That is np dot intersect 1d of x comma. So common elements are just that. Okay. Now let's move further, and so far in the NumPy, we have actually understood the various the creation of the arrays, and once we have created the arrays, right, we know that how to generate various splits, various types of joins, and then let me check what we have covered. And the swapping of the axis we have done. Then we have, right, done, we have looked at the u functions, right, universal functions, etc. Now let me look at what else we can cover. And yeah, one more thing I can teach you, how to create the own function, right? This is one important thing, and that will be the last topic under NumPy that we are going to discuss. Right, how to create own u functions, right? So in order to create a u function, we have what is called as a built-in function, and that is from py func. So this can be used. So let's try to use it now. Say I define, right, my add. I'll pass two numbers to this x and y. Okay, first you need to define a function, so you just have to return x plus y. Okay, now this actually expects what function you are passing, how many inputs and how many outputs, right? This needs to be specified. So this is the function, that is number one. So the number one is function, that function is my add. Now, right, I'm trying to create a u function, right, by, right, my u func. This is equal to np dot from, because it says that from pi to function, right? You will specify which function you want to use. That is my you will say that there will be two inputs and there will be one output. So it's the same order. Which function, how many inputs, how many outputs? Two inputs, one output. This actually creates your my u func, which is a function, universal function that you have created. All right, so let's look at the result. That is my u func. This is the name I have given. I just have to pass, right? Maybe you can pass even arrays, right? 1, 2, 3. That's first input. Second input is maybe, right, 5, 7, 9. Right? So you see, that's it. 5 plus 1, 7 plus 2, 9 plus 3. Okay, now you can actually check whether checking whether it's a u function or not, right? I can use type of, right? It says that yes, it's of type numpy u func, right? So if it is not a u func, right, it will return a different type, right? So I can show you an example here, right? You check that which is not a universal function, concatenate, right? So let me check that type of np dot concatenate. You see that my mistake, concatenate. It says it's a function, right? It's a built-in function, so it will identify that. Okay, so anything which is other than u func, it will say that it's a function, it's a variable or something like that. But if you have a u func, right, since I checked the one which I have written, but you can check with the others also, whatever u funcs we have come across in today's session, right? You can check that as, and you can actually, right, try to you'll find that that's also a u func. All right, so that brings us to the end of the NumPy session.